Okay, so we're now going to move into some of the various fitting routines, the Sherpa commands. We're going to start with kind of the workhorses, which is spectral fitting. You know, kind of the running joke is images are pretty, but science happens in the spectra. It's not always true, but it's kind of a good way to look at things. So here we have an ASIS data set, and we're going to extract the spectra and fit the spectra for this source here. So I can go into region edit mode, select my source. I could set up a background, but this source is so bright, background really is not going to affect anything. So then we go to Chow, and we're going to go into Sherpa. And we'll tear that off. And then we're going to do a spectral fit. And we get a big menu with lots of options. So we kind of have three different model components. We have what's the spectral model, and we're going to use a power law. Do we want any additional model components that are being added in? And for right now, we'll leave this as none. And then what is the absorption model? We can group it. The important one here is kind of the energy range, so I want to fit between 0.3 and 7 keV. That sounds good. And the fit method and statistic, we'll leave those alone. So what the script is doing now is it's actually gone off and it's starting to run the spec extract task. So this is the same chow task that we recommend users use. It automatically extracts the spectrum. It creates the ARF. It creates the RMF. The RMF usually takes a little bit of time, which is why I'm wasting time here. And then it goes and now it's ready to start fitting. So it's now gone into Sherpa. Well, let's see what we can do this here. We now have, this is a new model editor. So once the fit is ready to start, it guesses the parameter values that it can using the Sherpa guess command. And then it brings up this editor that you can then change the fit parameters. So the first thing to kind of do is to plot it. So we can now see, this is the data. This is our model. Obviously, it's horrible right now. I'm just going to go ahead and fit. And you can see that the fit happened, or I'm telling you that the fit happened. The fit values have changed, and they've also changed here in the GUI. And now I can replot this guy. So now we have the data, the model, and the residuals, and you can see it's not too bad. There seems to be something over here, some kind of line. This is around 6.7 keV, which is the iron line. So maybe we should add that in. So I'm going to go ahead and just exit out of here. And the script will go through and compute confidence intervals and things. But for right now, I want to come back to the spectral fit and just repeat the same thing, except for this time I'm going to add a Gaussian. And we'll let it run. You'll notice that because it's already run the spec extract before, and I didn't change anything in the region as far as the regions go, it's just using the same spectral it already extracted. And now the model editor comes up, and we have a second model component. For whatever reason, whenever the guess happens, it really likes the Gaussian more than the power law. So it really tries to if I were to plot this right now, you can see it really wants the Gaussian to be there. So I'm going to kind of manipulate this guy a little bit. So I'm going to force the line energy to be 6.7 keV, and I'm going to freeze that. And the other thing I want to change here is the normalizations. This is way off. 0, 0. Plot. Okay, that's not horrible. So I can now go ahead and try fit, and we see that it updated those, and I'll plot the fit. And we can see that this has taken care of a large part. It seems to be off a little bit, but seems to have taken care of the residual there. So again, I can now let this finish. Oops, sorry, exit. So we get all the model parameters, whether they're frozen or thawed. We get the integrated photon fluxes and the energy fluxes. And like the other tasks, we also get the data files that were created. So we can actually go to this directory, and we can see the spectrum, the ARF, the RMF, and then actually the commands that are used. So group counts, notice, and so forth and so on. So you can use these files as kind of a starting place of, if you want to advance a more advanced model, you want to add more components, you want to try different fitting methods. All the files are here that you can springboard off into your more detailed analysis. And that's kind of it for the spectra.